Hi again, folks. Now that we've learned about vectors and iterators, it's time to move on to the really powerful stuff the STL provides us, algorithms. There's a group of algorithms in the STL that allows you to manipulate the different elements in your containers through iterators. They exist for common tasks like searching, randomizing, and sorting. In this next program, we'll practice using algorithms that search, shuffle, and sort the elements in a container. Now, the first one we'll look at is the find algorithm. The find algorithm searches through a specified range of a container's elements for a specific value. For example, iter equals find scores.begin, comma, scores.end, comma, 1400. This would search from the beginning element to the end of the vector for a score matching 1400. If it finds it, the algorithm returns an iterator that references the first matching element. If it doesn't find it, the algorithm returns an iterator pointing to the end of the range. Now, the next algorithm is the random shuffle algorithm. We've seen how to generate random numbers by first seeding the random number generator and then using the rand function to generate the number. Random shuffle, what it does is it randomizes the items in our container and then saves the newly sorted sequence. You can use this to randomize a list of high scores, shuffle a deck of cards, or mix up the order of the enemies a player will encounter in a game. Now, it's important to note here that you do still need to seed the random number generator with srand before calling random shuffle. And then the last algorithm we'll look at is sort. The sort algorithm sorts the elements in a container in ascending order. You have to give the algorithm the starting and end point of the sequence as iterators so it knows what range it's supposed to work with. So let's go ahead and look at how these algorithms can help us in our program. Okay, we're creating a new C++ file, and I will save this in week 6. As highscores.cpp, and we begin. High scores demonstrates algorithms. Okay, so I start off, I include IOStream, and I include vector. I also need to include the file that provides these algorithms, which is called algorithm. And because I'm using randomizer and I have to seed my random number generator, and I need to use the time for that, so I include ctime. And the random shuffle algorithm does need to call on things from the C standard library, so I include that. Next, I declare that I'm using the std namespace, and I open up my main function. Okay, first we're going to create our vector iterator. Called iter, and we'll create a list of scores. We'll create a vector, an integer vector called scores. And in scores, we will push back 1500, push back 3500, and push back 7500. Okay, we'll display a list of our high scores. And we'll use our for loop to spit out the list. For iter equals scores begin, run as long as iter is not equal to scores.end. And after each loop, add 1 to iter. And we'll see out our dereferenced iter to give us the actual score value. Close our loop. Now, we'll look at finding the score. We'll create an integer called score. Not scores here, just score. This is going to be used for input from the player or from the user. We'll tell them to enter a score to find. And we'll see in that value into score. Now, we'll use our find algorithm. Iter equals find, and in parentheses, scores.begin, scores.end for our starting and ending point, our range, and score for what we want it to find. Now we'll say if iter does not equal scores.end, then we want to display that the score was found. On the other hand, if the score is not found, we want to display score not found. Okay, next we will randomize our scores. Okay, we'll seed our random number generator. And then we will random shuffle from scores.begin until scores.end. Now we'll display our high scores again. And we'll have a for loop for iter equals scores.begin, run as long as iter is not equal to scores.end, and add 1 to iter after each loop. Then we see out our dereferenced iter, followed by an end line, and we close our loop. Okay, so that will randomize the scores. Next, we'll sort them. See out sorting scores. We use our sort algorithm to sort from scores.begin to scores.end. And then let's just copy and paste this because it's exactly the same. We want to print out our high scores list again. And that'll do it. And finally, we'll return 0 and end our main function. And now I save that. And I want to get into the right directory here. Okay, so let's compile high scores. Oh, let's see, line 28. What did I do there? Oh, I left off the N. Let's try that again. No, something else. Line 46. I left off the semicolon. Hey, the way I found that was I looked at line 46, which is my error message said that it expected a semicolon before 4. So when I go down to 46, I see the 4 statement. I look up, I'd left off my semicolon. And I'm probably going to have that here as well. Add that back in. And now let's see what happens. There we go. Okay. So it's given us a list of scores, and it's asking us to enter a score to find. I'll go ahead and enter 1500 this time because that one is there. And you can see that it said that it found it. Then it randomized them, and not many numbers here, so basically all it did was swap 7500 for 3500. And then it sorted them, and it displayed them in the proper ascending order. Now let's run it again. This time I'll put 1400 for a score to find. And you can see it says score not found. Randomizing, this time we've got 3500 first, then 1500, then 7500, and then it properly sorts them. Okay, so that's sorting, shuffling, and finding. In the next segment, we will look at vector performance and how we can minimize performance problems related to using vectors. So stay tuned.